Here we are to use transformations of the graph of y equals 1 over x to graph the functions and give their domains and ranges. First of all, we start with the function y equals 1 over x, which we will remember is a hyperbola. It contains points where the coordinates are reciprocals of each other. So -10 and -1/10, 2.5, and also 1, 1, and -1, -1, etc. We want to know the graph of this function as one of our basic functions that we can just automatically sketch. In this case, we're given the function r of x equals 1 over x plus 4. And since x has been replaced by x plus 4, we will go 4 units to the left. That means that instead of our vertical asymptote being the y-axis, it will actually be at x equals -4. And we can sketch the graph here. And 1, 1 will move to -3, 1, and -1, 1 will move to -5, 1. So the domain has to exclude x equals -4. That's where the denominator is undefined. So it is the interval from -infinity to -4 union -4 infinity. The range will remain -infinity to 0 union 0 to infinity. That's the same range as the original y equals 1 over x. When we move to the second example, we have g of x equals -2 divided by the quantity x minus 2. So again, we start with 1 over x, and we move to 1 over x minus 2, and from there to -2 times 1 over x minus 2. So we'll be going 2 units to the right, then we'll be stretching vertically with a factor of 2 and flipping over the x-axis. If you prefer, you can leave the flipping over the x-axis off and say that the factor is -2. So here we're starting with the original hyperbola, asymptotes at the x and y axis. We're moving 2 units to the right. So the vertical asymptote is now x equals 2. Points on the graph would be 3, 1, and 1, -1. And for the last step, we'll be moving we'll be multiplying the second coordinates by -2 And so 3, negative 1, 3, 1 will go to 3, negative 2. And 1, negative 1 will go to 1, 2. And although there's been stretching and flipping, the horizontal asymptote is still at the x-axis. So the domain has changed to x not equal to 2. So the domain is the interval from negative infinity to 2, union 2 to infinity. And the range is still negative infinity to 0, union 0 to infinity. In the third example, we have the quotient of two linear functions, and therefore we can find the asymptote by dividing the leading coefficients, and so the horizontal asymptote is going to be y equals 2. But we actually want more information this time, so we're going to divide the numerator by the denominator. And when we do that, we get a constant term of 2. 2 times 6 is 12. The remainder is going to be 5. And so g of x this time is equivalent to 2 plus 5 over x minus 6. So we're going to go from 1 over x to 1 over x minus 6 to 5 over x minus 6, and finally to 2 plus 5 over x minus 6. So we'll be going 6 to the right. We'll be stretching vertically by factor of 5, and we'll be going up 2. So our asymptote vertically will be x equals 6. When we do that, we'll change 1, 1 to 7, 1, and negative 1, 1, negative 1, negative 1 to 5, negative 1. When we do the vertical stretching, this time I'm going to change the scale, and you won't be able to see the vertical stretching very well. But the 0.71 will now be at the 0.75, and the 0.5 negative 1 will now be at the 0.5 negative 5. And then when we move up 2, we'll be moving up to the point 7, 7, and the 0.5, -3. So we need to avoid y equals 2 and x equals 6. The domain is -infinity to 6, union 6 to infinity. The range is -infinity to 2, union 2 to infinity. The third, or the fourth example, the last one, the quotient contains two linear terms with leading coefficient 1, so the y asymptote will be y equals 1. When we do the actual division, -6 is divided into 1, 5. The constant is 1, and the remainder is -1. So the quotient is equivalent to 1 plus -1 over x plus 6. And so in this case, we will start with the 1 over x. We'll move to 1 over x plus 6. We'll then multiply that by -1. And lastly, we'll add 1. So our 1 over x plus 6 is going to move 6 units to the left. So here our graph will have vertical asymptote x equals -6. And we'll go through, instead of 1, 1, it will go through -5, 1, and it will also go through -7, -1. The -1, when it's multiplied, will flip the curve over the x-axis. So a vertical flip, and so what was -5, +1 will become -5, -1. And what was -7, -1 will become -7, +1. The curve is then going to be moved up 1, and so -1, -5, -1 will be right on the x-axis, and -7, 1 will be at -7, 2. So the domain is everything except x equals -6, and the range is everything except y equals 1.